Hi there, welcome to the practice questions on being able to factorise quadratic expressions. What I'd like you to do now is to pause the video and have a go at these three questions, and then when you're happy with your answers, then restart the video and look through the model answers and see if you've made any mistakes. So if you pause the video now and have a go at questions 1, 2 and 3. Hi, welcome back. Let's now go through these three questions. Question 1. We've got a quadratic here, x squared plus 17x plus 70. And what we need to do is we need to put this into two sets of brackets, a set of double brackets. The way we do this is we look at the last number here, the 70. And we're looking for two numbers that multiply to give us 70, but that also add to give us 17. Combinations of these numbers, you could have 1 and 70. You could have 2 and 35. You could have 7 and 10. So if we look at these, we've got 1 and 70. Clearly that will not add to give 17. 2 and 35 gives you 37. That doesn't add to give 17. But 7 and 10 will add to give 17. And all we need to do now is put it in our double brackets. Can write x in the front of both of them. And our two numbers we've found are 7 and 10, and it's just simply a case of putting those in, x plus 7 and x plus 10. Because these are both positives, the signs inside the brackets must be both positives as well. Question 2 then. Now this time we've got a negative 12 here. So we need two numbers that multiply to give negative 12 and that also add to give 4. Little bit more complicated. So let's write down our combinations. You could have 1 and 12. You could have 2 and 6. You could have 3 and 4. Now we've got to look at each of these in turn to see if they can possibly add to give out 4 here. But remember, because it's a negative 12, to multiply to give a negative, one needs to be a negative, one needs to be a positive. So we need to try each of these. So let's have a look at the 12 here. So if you've got minus 1 add 12, that's going to give you 11. If you rub that out, so you then had the minus here, and you've got minus 12 add 1, well that's going to give you minus 11. None of these combinations is going to give you a positive 4, so it can't be that first one. Let's have a look at the second one then. Let's put a minus in front of the 2. Minus 2 add 6 takes you through 0 up to positive 4. So here, minus 2 add 6 gives you 4, so we now know that this is our combination of numbers. So again, like the first one, put your x in here and your x in here, and then this time though, because it's minus 2 and 6, it must be a negative in the first one and a positive in the second one. Doesn't matter which way round these go, you could have x plus 6, x minus 2, but as long as the signs are in the correct place. Okay, the last one then. We've got to have two numbers that multiply to give us 18 and also add to give negative 9. Now we could have 1 and 18, we could have 2 and 9, or we could have 3 and 6. All of these, each of these three combinations give us an answer of 18 when we multiply them together. Now we have to get an answer of negative 9 here, so let's do the same thing. However, this time, to give a positive 18, the numbers must both be positive or both negative. Now there's no way that they can both be positive because that could not give us a negative answer when we add them together. So both of these must this time be negative. So if we put a negative in front of each of them, negative 1 add negative 18 is the same as negative 1 take away 18, which is negative 19. That does not work. And then negative 2 negative 9, well, negative 2 add negative 9 is negative 11, so that one doesn't work. So the last one, negative 3 and negative 6, negative 3 add negative 6 gives us our negative 9. So this is the combination that we're looking for. So here, if we open up our brackets again, double set of brackets, x goes in the first one. We've already established this time that both our answers are negative, so we can put a negative in there. And let's just write it the other way, x negative 6 and x negative 3. Remember I said it doesn't matter which way round these go.